Hi again, this is video 3 of our solutions unit, and we will go over solution features. A solution is a homogeneous mixture of two or more substances in a single phase. If something is soluble, it can be dissolved. Sugar is soluble in water. So when sugar dissolves, its molecules become uniformly distributed among the water molecules, and the solid sugar is no longer visible. Solutions can exist as gases, liquids, or solids. You may be more familiar with liquid solutions, but the other two are possible also. The dissolving medium in a solution is called the solvent. It is the substance in the largest amount. It is often a liquid, but it can be a solid or gas. Remember that water is the universal solvent, so the solvent is often water. The solute is the substance being dissolved, and it is the substance in the smallest amount. It is usually a solid, but it could be a liquid or a gas. Solutions can exist, as we said, as gases, liquids, or solids, and there are many possible solute-solvent combinations. So please pause the video and be familiar with some examples of different solute-solvent combinations, as you can see in this chart. We are going to look at 3 types of mixtures: true solutions, colloids, and suspensions. All mixtures have an indefinite composition, which means that they vary in their composition. Only elements and compounds have a definite composition. Let's look at the characteristics of true solutions. True solutions are homogeneous mixtures, which means that they are uniform throughout. The particle size is less than a nanometer, which means they are atoms, ions, or molecules. Solutions cannot be separated by filtration. The particles don't settle out. That is, they're not affected by gravity. True solutions do not exhibit the Tyndall effect. The Tyndall effect is the scattering of light. We'll look at that a little more when we look at colloids. Some examples will be sugar water, salt water, which is also called saline, a 1 molar solution of copper 2 chloride. Let's look at colloids. Colloids are heterogeneous mixtures, which means that they are not uniform throughout. Now, they do look uniform throughout, but they are still heterogeneous because of the particle size. So the particles are intermediate in size, and they are in between those of suspensions and true solutions, between 1 and 1,000 nanometers. The particles in a colloid are small enough to be suspended throughout the solvent by the constant movement of the surrounding molecules. And this chaotic movement of particles is called Brownian motion. The particles stay suspended because they have layers of charge that repel each other. The particles are small enough that they cannot be separated by filtration, and they do exhibit the Tyndall effect. So if you look in this picture here, we have light going through a solution, and it is not scattered, but when it goes through a colloid, we can see the scattering of light over here. Colloids can be solid, liquid, or gas mixed with any other phase. Some examples are mayonnaise, fog, gelatin, paint, milk, and many more. Suspensions are heterogeneous mixtures with particles approximately 1,000 nanometer or greater. It is easy to see the particles in a suspension. So the particles are larger than those in a colloid or in a solution, and they settle out over time. That is, they are affected by gravity. And we can see that in this picture of muddy water over here. The particles are suspended throughout, and as time goes by, they settle out until they are completely settled out in the last jar here. Particles can be separated by filtration. Here we can see a suspension of chalk in water being filtered out. The chalk will stay on top of the filter paper here, and the water, which is called the filtrate, will go through so you can separate it out. When suspended, the particles do reflect light and exhibit the Tyndall effect. So again here, if I shone light through this, it would scatter. But once the particles are settled out, Tyndall effect will not be observed above the settled particles. Some examples are muddy water, Italian salad dressing, a mixture of sand and water, and many more. This table summarizes the properties of solutions, colloids, and suspensions. Again, you can pause the video and take a look at that table. The action of a solute dissolving into a solvent until the solute is stable is called solvation. When water is the solvent, we actually call this hydration, and the solution formed is an aqueous solution. So during solvation or hydration shells form around the solute particles. Here we can see the negative side of the water molecule being attracted to the positive sodium ion in sodium chloride, and the positive hydrogen side of the molecule being attracted to the negative chlorine ions in sodium chloride. And we form these hydration shells around the ions. Electrolytes versus non-electrolytes. We've talked about this before. A substance that dissolves in water to give a solution that conducts electricity or an electric current is called an electrolyte. Any soluble ionic compound, or salt is another word for that, such as sodium chloride or copper 2 sulfate, for example, will be an electrolyte. What happens is the positive and negative ions separate from each other in the solution, as we can see in this beaker. They are free to move, important, and that makes it possible for an electric current to pass through the solution. All soluble salts and soluble ionic bases will be strong electrolytes because all the ions dissociate and go into the solution. When covalent compounds dissolve in water to produce ions, this process is called ionization. Now, most covalent compounds actually do not undergo ionization. We've talked about that before. They do not form ions. However, acids are an exception. All acids produce hydrogen ions or hydronium ions. We will learn about hydronium ions a little more in acids and bases. And they produce those in solution. Then the ions are free to move, so it is possible for an electric current to pass through the solution. Strong acids, which are those that ionize completely in solution, will be strong electrolytes, and weak acids, those that do not ionize completely, will form weak electrolytes. So we can see here hydrochloric acid is a strong electrolyte. All the HCl has formed H plus and Cl minus ions. On the other hand, acetic acid, which is H2CO3, some of them are still molecules in that solution, and a few have formed ions. So it has ionized partially and will be a weak electrolyte. A substance that dissolves in water to give a solution that does not conduct an electric current is a non-electrolyte. Sugar would be an example of a non-electrolyte. Like we said, most covalent compounds do not undergo ionization when dissolved in water. The solute particles are neutral molecules, so they do not have charged ions and they cannot conduct an electric current. So this is a good picture summary of electrolytes versus non-electrolytes. In a sucrose solution, the molecules are neutral, so we can see that the light bulb does not light because there is no movement of charged particles. In an acetic acid solution, we said that acetic acid is a weak acid, so it ionizes partially, and the light bulb is pretty dim. It is a weak electrolyte. In a sodium chloride solution, all the sodium chloride produces ions, so we have a strong electrolyte and the light bulb is fairly bright. Same thing for hydrochloric acid. It is an acid that ionizes completely, so lots of ions in the solution and a bright bulb, so a strong electrolyte. That's it for video 3. You should have taken good notes. Come to class prepared with your questions.